All right, good morning. I just want to go over the code that I'd written the other day for you to use as a jumping off point for the assignment. Remember, the assignment's pretty simple. All you need to do is simulate a ball being tossed in the air with gravity pulling it down at 9.8 meters per second squared. And the question is, if it's thrown with said velocity, how high can it go? That's the point of the code. So let's get at it, and we'll see where we go from there. Here's the code right here, as you see it. Let's just give it a play, see what it does. Okay, so you notice, like in previous examples, it's moving much slower. It's because I'm using it at full animation, or full animation speed, but I've applied a time step, and that's kind of one of the things I want to go over with you. There is a new thing going on. So I do want to there is a new thing going on, so that's what I want to kind of talk about here. So again, let's just start at the top. There's the time step. This is how I change the amount of time between intervals. So if I wanted to have at a 1/10 of a second intervals, the ball does appear to be moving faster, but that's just because the steps between everything has increased. I can adjust the time step. I can adjust the distance between pixels. Okay, there is this thing, object. We'll talk about that later, but this is just a global variable. Okay, you will notice some new stuff here. In fact, you will notice the word new, because I've gone ahead and turned object into a class. And so this allows initiation. Now, I've done a lot of things in this code that are not the proper way to do it coding-wise, so that I'm not hiding things from you in the implementation. Because I want you to see what's going on. It would have been very easy for me to write all the functions, and then you just use them without understanding them. So scrolling down here, we still have a draw object. The draw object is I want to point out, this is very important. I want to point out that in draw object, that function draw object, we talked about functions before, this is where the code converts from real world units to computer screen units. So anytime you give a number up here, anytime you're giving a number up here, you're giving a number as if you're using real units. So if you're setting a velocity of 5, that means 5 meters per second. If you're setting an acceleration of 2, that means 2.2 meters per second squared. So I mean, I could go ahead and change this to 9.8, and we can see what the right. And then I could throw the ball maybe at 25 meters per second, and we can see what it does. In fact, you know, if you need a little bit more space, you can increase the size of your canvas and do that. And so now that increases the width, the height of it. That increases the width of it. All right. Ignore the blue square up there. The blue square up there is just there because I was testing things out, and I haven't removed it. So I should probably say, ignore me. Okay. So anyway. Let's go. So the draw object just draws a circle of size 30-30 in that place. Okay. I made 2 functions. These functions convert meters to pixels and pixels to meters, so that if I need to do that calculation, I have a function to do it. That's not where we're at. So here's the class. These don't worry about so much, but here's what it is. It's pretty simple that I can pass the class 2 positions, and we saw this with objects earlier. So what a class does, it lets me make a generic object that I can make multiples of. And that's all this is doing, is I have one function that lets me set the values of the velocity vector, and I have one that lets me set the values of the acceleration vector, and the position vector is set when the class is created. That's what the constructor does. So when we come up here to line 10 of the code, this is where you're creating a new object. Now, why is this not called an object? Is because that's a reserved word, and that got me into a lot of trouble calling it an object. So didn't work out. So here is setting the position, setting the velocity. So that's all the setup is doing. Probably can get rid of this part right here, not need it. That was just for debugging, just to let me know things were working. I know they're working now, so I'm good. Coming down to here, let's just go through the draw function real quick. Background, set the color, draw a rectangle. That's that blue rectangle. As I said before, I just did this because I was running into some weird issues and I had to debug it. So when you're writing your code, feel free to ask for help, and more importantly, understand that debugging is going to take longer than writing. All right, so what's the first thing I do? So I draw the object, right? Now, that's the first thing I do. Draw the object. What is the object? The circle. Draw the circle. Then let temp. We'll go back to this later, but I want to be able to multiply my time vector, my vectors, by a multiplier, because I don't want to move a full second. Remember, velocity is being given in meters per second. Acceleration is given in meters per second, or meters per second squared. But my timestamp is not a full second, it's 0.05. So we talked yesterday, well, last time I saw you, talked Tuesday about how multiplying a vector by a scalar. Now, if I just multiply, if I just use the multiplying function, it changes the original one. I don't want to do that because the velocity is the current velocity it's moving, but I don't want to move a full second. I just want to move a time step of the second. So that's what this temp allows me to do. This creates a temporary value that I can put that shorten vector on. It's still pointing the right direction, it's just shortened, and then I add that to my velocity. So here I'm doing the acceleration. I'm multiplying the acceleration by the time step and then adding it to the thing, and then I'm then doing the same to the velocity vector and adding that to the position vector, and then doing all that. This code right here, if I would run it again, this code, you will notice that we are getting the position vector printed out at the top right, and so that's what that is doing there. Again, if you want to slow things down, might as well do this. You could put a frame rate in here. This will not change the accuracy of your calculations. This would just change the rate at which the playback is. So this is just changing the rate of playback. That's all this is doing, because the frame rate is no longer, unlike previously with the frame rate in the previous example we did, is frame rate was controlling the time step. In this case, the frame rate is not controlling the time step at all. It's just controlling how quickly each calculation is done. And you can see very clearly this is the ball's position. Remember that 0, 0 is up here. So at some point you might need to do some clever code if you want 0 to be down here at the bottom to flip things around. All right, I think that is a brief overview. So again, we draw the object at its current position. We create a temporary vector, which is the acceleration times its time step, which, the acceleration vector is this big. Multiply it by a smaller number, and it becomes this big. Add that to the velocity, which changes the velocity, and then do the same with velocity, multiply the velocity by a time step. Okay, there it is. I hope this is useful to you.